All right, so it says a fishing boat leaves Tampa Bay at 4 a.m. and travels at 12 knots. At 5 a.m., a second boat leaves the same dock for the same destination and travels at 14 knots. How long will it take the second boat to catch up with the first one? All right. So for our chart here, we will have the first boat and we will have the second boat. Okay. We still have a rate, a time, and a distance. What type of problem is this? Are they going opposite directions towards each other or same direction? Same direction. They actually leave at the same spot and they catch up obviously at the same spot. So what do we know about their distances? They are the same, okay? So how fast is the first boat going? 12 knots, all right? How long did the first boat travel?
2 hours.
So the time here is T. What about the second guy? Do we know how long this guy traveled? So we know its rate. What is his rate? Second one.
14.
It is 14. Do we know his time? No. What do we know about his time? He left an hour later. So did he travel an hour longer or an hour less time? Less time. How do I say an hour less? T minus 1.
Why do you travel an hour less?
Just like on the bell work. You could have said T plus 1 and T. As long as the guy that's traveling longer and short, like as long as you have it set up correctly. So you could have said he left an hour earlier, so he traveled 1 hour longer. And you could have said this one is T plus 1 and this one is T. Okay? But pay attention, when it is same direction and the distances are the same, the guy that is traveling faster should be traveling less time, okay? Because it's the same distance, all right? So if this is T, this has to be T minus 1 because he's going faster. Make sense? Or vice versa. This has to be T and this has to be T plus 1 because he's going to be traveling longer because he's going slower. And how do we find... So, how do I find the distance? What is the distance?
The first one is
12t. All right. What about the second one?
14t. Well, it's over 15.
All right. What do we know about their distances? They're the same, so we have a very simple equation here. How do I solve it?
14t minus 14 equals 12t.
14t minus 14. Yes? All right. How do I solve this?
You subtract 14.
Variables on one side, numbers on the other, right? What's 12 minus 14? So what is t here?
Equals
T equals 7.
7.
And 7 hours equals the first boat. And then we just minus the 1, which equals 6 hours for the second
Right.
boat.
All right. They were specifically asking about the second. So if I set it up like this, then I have to say 6 hours would be my answer because he traveled 1 hour. But when you have mixture problems, it is, as it says, a combination of different substances. And so what will happen is they'll say it is this percent of this mixture and this is this percent of that mixture. And what we want is we want a total mixture at this percent. And so you have to kind of set these up a little bit differently. You actually have a little bit longer of a chart. All right, let's look at the first one, the first example here. A feed store owner wants to mix corn and barley to make 150 BUs of silage additive for cattle feed, okay? If the corn costs $3.80 per bundle and barley costs $2.60, how many bushels of each grain would he mix to yield an additive worth $3 a bushel, right? And so we have multiple things going on. First of all, we have two different types. We have corn and we have barley. And so that's the first part of this chart that we're going to set up. We're going to set up corn and we are going to set up barley. All right. And then we are going to set up one for our final mix. Our final mix. All right. Now for this, we have a count column and we have like, in this case, a price column. We're going to do some with percentages as well. And so you have kind of an amount for each piece, and then you have an amount for the total. So we have the number of bushels for this particular one. And then we have the price per bushel. And then we have a total cost. All right. So do we know the number of bushels of corn? Do we know the number of bushels of corn? We do not. So we're just going to say X here. All right. Do we know how much the corn cost? Yes. How much does the corn cost? So if I have the number of bushels and the price per bushel, how would I find the total price? What would I do with those? You would multiply, right? If I take the number that I have times how much it costs per thing, I would multiply across. So what's the total cost of the corn? 380 times X, right? You could just say 3.8 because we don't have to worry about that 0. What about the barley? Do we know how much the barley costs? I mean, the barley, how much barley we have? We don't, right? But we do know something else. We know the total amount, right, that he wants. He wants in total 150 bushels of all of it, right? Does that make sense? At the very beginning, he says he wants to mix corn and barley to make 150 bushels of additive. So we can jump down to this total mix here, right? And we know this is 150. Just like the time, think about how we did time. When it was total time, what did we do? If we had one of them, what did we do to find the other? When we had total time? Yeah, we subtracted. When it was total 6 hours and we had one of them as T, we said 6 minus T for the other. The total is 150 bushels. We know one of them is X. How do we solve for the other one? Subtract. So we're going to say for barley, we have 150 minus X. Does that make sense? If we take 150 and we subtract how much corn, then we should have how much barley is left, right? Because he wants 150 in total. We also know the cost of the barley. What is the cost of the barley? Yeah, it is $2.60. So then what is the total cost?
2.6 times.
And then make sure, what do we do here? Parentheses, right? Always do parentheses there. Okay? Always do parentheses here. So his mixture is going to be 150 in total, right? And the cost is going to be how much per bushel? $3. He told us that's what he wants to do. $3. So what is going to be the total cost of his mixture? Just multiply like we did everything else. This has all been multiplied. So 150 times 3. What is 150 times 3? 450. Right? Does everybody see how we filled out the chart? All right. Now let's talk about how we solve this. I should be able to add the cost of my corn to the cost of my barley and get the total cost. All right, so we are going to set them equal. We're going to add them up and set them equal to 450. So we're going to say 3.8x plus 2.6, 150 minus x equals 450. All right, and so now we're going to distribute and solve, right? Distribute and solve. So we're going to say 2.6, distribute that through. So 2.6 times 150 gives you what? 3,900. Oh, they just took them out. Okay. They took out their decimals. That's fine. 2.6x equals 450. Yeah, if you want to get rid of your decimals, you can. It doesn't matter either way. But remember the shortcut, you could bump all them over. That's what the book did, so just pay attention when you see it bigger. All right, so 3.8 and negative 2.6 are like terms. So I'm going to combine those. What is 3.8 minus 2.6? Hopefully 1.2. Yes. Plus 390 equals 450. How do I solve?
Subtract 390.
Subtract 390, right? So I get 1.2
You get 40.
x equals 60.
Oh yeah, it is.
Yes. And then divide by 1.2. 60 divided by 1.2 is 50 bushels. Well, all right, 50 bushels. What did they ask? Did they ask for just one of them? No, they want how many of each type. Which one did we solve for? Which one is 50? The corn. So this is 50 bushels, right? We know the total is 150. So what do we do with that 50 to find the barley?
It would be 100 track.
Yeah, 150 minus the 50, it should be 100 bushels of this guy. And that is our answer.